I think it's the 6th. So let's talk about radical expressions. And fractional exponents. They're the same. They should be taught or presented together. Okay. So radical expressions and fractional exponents. Well, we will have a need to find the square root of 4. So this is the positive square root. And the answer is 2. Why? Since, what is the index of this radical? I don't see an index here. If there is no index, by convention, it's 2. We never write index 2. So the square root of 4 is 2. Since 2 raised to this power, 2 raised to this power is 4. What about the cube root of 8? What will that be? Let's say we don't know, but it's the number that I raise to the 3rd power to get 8. Which number do I raise to the 3rd power to get 8? 2. Obviously, it's 2. Okay, let's look at one more. Let's say the 4th root of 16. Let's say I have no idea. But it's the number that I raise to which power? Very good. To get 16. And I know there is only one number. Which number? 2. So, in general, the general formula, this is index n, lowercase n. A is any number to power m. So this is the power, or exponent, and this is the base. How do I read this? Let me put this in writing for you. How do I read this expression, this format? The nth root of a raised to the mth power. A lot of words. The nth root of a to the mth power. This can be replaced by an expression with fractional exponents, always. If I see an expression that has an exponent that is a fraction, I immediately think of a radical. If I see a radical, I know I can change it into an expression with an exponent that is a fraction, back and forth. So here is the answer or the conversion of this. A, the exponent is a fraction. The exponent, the inside, it will always be the numerator. The index will always be the denominator. And this is extremely important because it will help us in simplifying radical exponents. So we need to remember that the square root of 3 is the same with 3 raised to which power?
Well, inside the radical is 3 to the first.
Yes?
Look at that as the top part of the fraction.
Yes, excellent. Power 1, so it's 1 over The index cannot be lower than 2. Let me mention that. My apologies, I should have. N can be 2, 3, 4, and so on and so forth. There is no 0, there is no negative number, and there is no 1.
And there's no decimal, no fractional decimal.
In situations it could be, but let's say no, that it's not for us. Good. So what is the denominator? Sorry about that. The denominator is 2. If we don't write anything, the index must be 2. When it's blank, the index is 2. Okay, what if I say x to 1/4? What does that mean immediately?
The fourth root of x.
Excellent. What if now I say x to 2/3? What would that mean? That the cube root or the third root, that's fine. The cube root of x squared. Excellent. Very good. So do we understand the conversion between? I just need to have the different examples ready here. Okay, do we understand the conversion now? Okay, one more. Let's say I have the 5th root of x cubed. What does this mean? X raised to power 3/5. Excellent. The index is the denominator, the power is the numerator. Are we okay with that? Perfect. So knowing this, I would like us now to see how, if you remember, how we simplify radicals. So let's suppose I have the square root of 8. 8 is not a perfect square. But I know that I can present it as a product, not sum, of two numbers, one of them being a perfect square, the other one not. Indeed, 4 and 2. Then I will be able to write, and I'm allowed to write the product, because as a refresher, the square root or any root, the nth root of a times b is the nth root of a multiplied by the nth root of b. This is one of the properties of the radicals. Here is another. The nth root of a over b is the nth root of a over the nth root of b. Well, of course, assuming everything is a real number. Complex numbers will be treated differently. So notice one thing, which is extremely important, that the square root of a squared plus b squared cannot be ever written like this. This is not allowed. Or if you have minus here, that's not possible. This can never be written. This will be totally wrong. I can split the radical if the radicand, the quantity under the radical, is a product. I can split the radical if the quantity under the radical is a ratio or a division. But I cannot split when it's a sum or a difference.
Although there are a couple of numbers that work, but it's very strong.
It doesn't. So if you write the square root of 4 plus 9, if you write the square root of 4 plus the square root of 9, they'll be incorrect. Because this is the square root of 13, and this is 2 plus 3. And the square root of 13 does not equal 2 plus 3. So please remember, you can never simplify a radical if the quantity under the radical is a sum or a difference. See here, sum or difference? No. Ratio? Yes. Product? Yes. Okay. So let's go back to more simplification of radicals. Now, here's the negative square root. We talked about the positive square root. But if we have this, This means negative 1 multiplied by the square root of 25, which is 5, but 5 multiplied by negative 1 will give us negative 5. And this is what is called the negative square root. So there is a positive square root and a negative square root. A negative has to be outside. However, when we look at this situation, we will say not a real number. So what we also need to remember is when it comes to odd index and even index. For example, the cube root of x, the 7th root of x, even index, the square root of x, the 4th root of x, the 6th root of x, and so on and so forth. The odd index, the domain for any function with an odd index, domain, all real numbers. No restrictions. No restrictions on odd indices. Friendly, nice. Everything, you can plug in everything. You can plug in 0, negative numbers, positive numbers. However, this is a totally different story. Here, this x has to be greater than or equal to 0. So is this. So is this. So the domain for this function is 0 to infinity. So every time we look at an even index, square root, 4th root, 6th root, we have to make sure that the quantity under that radicand, other than the radicand, which is the quantity under the square root or 4th root or 6th root, is always positive or 0. So here I see an even index, it's a square root, and I see a negative number, which is not allowed under the square root or the 4th root or the 6th root, etc. So that's why I will say this is not a real number. It's an imaginary number. Okay. Now specifically, they are presenting these two. So this is by construction, right? They meant this. They want us to simplify this. Would you change it into this? No, because it's a sum under the square root. So you will add 144 to 25. You will get 169, and then the square root is 13. But here, the square root is 12, and the square root is 5. So 12 plus 5 is 17. And here, 169, the square root of 169 is 13. So these are not the same. Now again, they are trying to trick us with this, because they want us to write negative 17, which will not be correct. Okay, so let's go back here to this table. Let's mention two more things. So we mentioned the domain. Okay. Let's also mention the range. For something like this, the range is also everything. So the result, when you apply the cube root to anything, you can get any real number. When you apply the 7th root to anything, you can get any real number, but not here. Here also the range is 0 to infinity. For a function like this, the square root of x, the 4th root of x, the 6th root of x, the 10th root of x, the domain and the range are positive, meaning not only that this quantity has to be positive or 0, but the result, the answer outside, also has to be positive or 0. So then, this is a tricky situation that they are showing us here. They say, find the square of negative 17 squared. Let me check on this. Yeah, I think it's working. Okay, so here is what I need to do first. I have to notice that this is two pieces, is negative 1 and 17. I have to raise negative 1 to the second power, and I have to raise 17 to the second power. But when I raise this to the second power, I get 1. And then I get the square root of 17 squared, and now it's okay to write 17. Why? How come? Because remember, we are changing this into 17 raised to power 2 over 2. 2 over 2 would be 17 to the first power. So please understand what's happening here. With the even indices, not only the quantity under the radical has to be positive or 0, but also the result has to be positive or 0. When it comes to cube root or any odd index, it doesn't matter. You can have anything you want under the root, and you can have anything you want outside of the root as an answer. So please remember that.
Professor,
Yes, please.
if you went back and looked at this, the square root of x squared,
Yes?
so
Let's talk about that.
it's similar to this problem.
Yes, so let's talk about that since you mentioned it. I would have gotten to it, but since you asked, let's do it now. There is a big problem, and we need to understand what's happening here. So you would normally say, oh, well, you just showed us how to change this into an exponential expression with a fractional exponent, right? You're going to copy x, you're going to copy the power, you're going to copy the index, and you're going to say it's x. Correct? Don't write it. It's wrong. Is this what we should expect to have? Right? That's what we discussed a minute ago, right? We said this over this, so we copied the base, and we wrote 2 over 2 for this particular situation, right? Is this, so far, it appears to be okay? Well, it's not true. So let's discuss this. If I have here the square root of 2 squared, this is, so in other words, I replaced x by 2 with a positive number. 2 squared, I get the square root of 4, which is 2. That's okay. What if I replace x by 0? It's okay too. It's 0 squared, which is the square root of 0, which is 0. It's okay. But now let's say, because this should be a general truth, it should work for any number, right? If it's true, it should work for any number. Let's now say that x is negative 3. What should I write?
Negative 3 squared.
Negative 3 squared. But remember, I cannot write negative 3.
So is it a case of your parentheses being in the wrong place? Maybe
Nope.
parentheses
Nope.
minus 3 to the second?
So you understand that this will mean it's exactly the same situation. So when I replace x by negative 3, I cannot get negative 3. So the formula, or what we just came up with, is not true. If I replace this by negative 3, I cannot write negative 3 here. This will be incorrect. We just did an example, right? I will have to write the square root of negative 3 squared, which is 9, and then the answer will be 3. But I replaced x by negative 3. So something is wrong. I cannot replace x by negative 3 and instead of x get something else, positive 3. So the correct formula is this. And now this is guaranteed to work for any real number. For any x real number. So this is the correct formula if we do not have x. If you say to me, well, but x is only 0 or positive, then I don't need the absolute value. But if you say x can be any real number, then I need the absolute value on the other side. And now, when I replace x by negative 3 here and x by negative 3 here, it's okay. It works fine. I do get what I need to get. I do get the correct answer. So be very careful. The square root of x squared is not x, but the absolute value of x. For the same reason we just discussed here. The domain and the range of something like this is always 0 to infinity. Very good question, Bob. Thank you. Okay, let's refresh our memory on how to multiply. Any questions? Do we need more simplification? Let's look at another. Let's say the square root of 120. I have no idea what 120 is composed of, but I'm going to say in prime numbers, it's divisible by 2, so then 60. 60 is divisible by 2, and then 30. 30 is divisible by 2, and then 15. 15 is divisible by 3, and then 5. I have a 4, and this is 6 times 5. That's not a perfect square. 2 times 5 is not a perfect square. Nothing else works. So then I know how to present the square root of 120 into 4 times 30. 4 times 30. And then I take the square root of 4 times the square root of 30 because it's a product and I'm allowed to split it. And then the square root of 4 will be 2. And then the square root of 30 will stay as is. And this is it. Any questions? Okay, so let's refresh our memory on how to multiply. Okay, assume that variables represent non-negative real numbers. So I don't need to use the absolute value. It says this in this exercise 18 on 48, the square root of 10x times the square root of 8x. They're telling us x is greater than or equal to 0. This is given to us. So then I will multiply because they have the same index. I will write the square root of 80x squared, of course. I will split it into the square root of 80 times the square root of x squared. Now this can be replaced by x. Why can it be replaced by x and not the absolute value of x?
Because there is no restriction they gave you.
Exactly, because they're telling us don't worry about it. Don't use absolute value, there is no need, everything is positive. But now I have to work on 80. So 80 is an even number. It's divisible by 2, 40. It's divisible by 2, 20. It's divisible by 2, 10. It's divisible by 2, 5. Now this is what I need. The 16 in this case. The square root of 16 times the square root of 5 times x. I split 80 so that I came up with a perfect square, which is 16, and a non-perfect square, which is 5. So then the final simplified form is 4x the square root of 5. We prefer not writing anything behind following a radical, just in case we make an error and think that the radical should be extended over x or something like that. That's the simplified form of this product. Questions? How will you simplify the square root of y cubed? The square root of y cubed. And this is problem 20 on 48. How will you simplify this?
So the general rule is you're trying to break the number into pieces where at least one part is, one factor is
Right.
perfect square.
Right. Exactly. So the best thing to write is this. Copy the base, add the exponents. So now you can write the square root of y squared times the square root of y. And the square root of y squared, since they are telling us that all variables are positive, then you will write y the square root of y. Any questions? Any questions? Let's look at division now. Ready for a division? Okay, so let's say 30 on 48. The square of 24x to the fourth divided by the square of 3x. I noticed that top and bottom they have common factors. Therefore, I will write just one radical because they have the same index. If they didn't, it's a different story. It would have been a different story. But I noticed that 24 and 3 have a common factor, and x to the fourth and x have a common factor, of course. So then I will simplify inside the radical, and I have 8x to the third. In the next step, I will definitely change it into a product of radicals because I can simplify each separately. Question so far? Okay, let's look at another. What about 32? Please stop me if you have questions, anything. Is this okay? Oh, of course not. So this is 2x. Thank you. The problem is telling us, it says, assume that x is greater than 0. So we didn't have to worry about the absolute value. Oh, I'm sorry. I'm thinking of a cubed. I'm thinking of cubed. I'm sorry. I'm sorry. I'm sorry. I'm sorry. I was just checking my video and I lost track of what I was doing. My apologies. Thank you. This was not a test whether you were paying attention or not. It was my brain not working properly. Yes, of course. So this is the square of 4 times the square of 2 times the square of x squared times the square of x, of course. My apologies. My apologies. Sorry about that. So, of course, this is 2. Of course, this is x, assuming that x is positive. So these two go in front. And then these two now, they're combined into one radical. So this is the simplified form of this radical. In my mind, it was the cube root. That's why I wrote 2 and x. Sorry. Is that okay? Perfect. Let's move on to another division. I was just looking at another division, if you'd like. And then we'll look at a review how to add and subtract. Ready? So this is 32 on page 48. So the square root of 500x cubed over the square root of 10x to negative 1. I will proceed exactly in the same way. Meaning, I see that both top and bottom have common factors. So obviously, I will rewrite with one radical. So this is the square root of 500x cubed over 10x to negative 1. 500 over 10, 50. And now careful, we copy the base. And what happens to 3 and negative 1? So we copy the base. What operation do I perform with 3 and negative 1?
Subtraction.
Always. From the numerator, the power of the numerator, I have to subtract the power of the denominator, which ends up being 4. So when we divide exponential notations with the same base, we copy the base and subtract the exponents. Only and always from the numerator, from the exponent of the numerator, we subtract the exponent of the denominator. Okay, so now I will split it, and 50 has to be presented as the square root of 25, the square root of 2, and the square root of x to the fourth. So instead of 50, we wrote 25 and 2, and we know the square root of 25 is 5, And we know the square root of x to the fourth is?
X squared.
Very good. We copy the base and we divide. Divide 4 by 2. So this is the square root of 2. And this is fully simplified. We can't do anything else to it. 5x squared times the square root of 2. Okay, let's refresh our memory on how to add and subtract rational expressions. You can always stop me and say, I need more examples of this or more examples of that, because I don't remember. I mean, I don't know exactly how much you worked on this in the previous course. I don't know. Okay, so here's an example, 36 on 48. 4 the square root of 13x minus 6 the square root of 13x. If these are like radicals, then we can combine them. If they are not like radicals, we cannot combine them. So let's see. Is the irrational part the same? Yes, the irrational part is the same. So then you can say 4 apples minus 6 apples. And the answer is negative 2 the square root of 13x. But what happens if we need to simplify before we add or subtract? Like, for example, 41. In 41, we have 3 the square root of 18 plus 5 the square root of 50. And we're asked simplify, subtract, etc.
Well, one thing is clear, you can't just add them.
So obviously we cannot. Because they're not like radicals. The square root of 18 and the square root of 50 are not the same. So we have to work hard on each and every one of them and see what happens. So I see that this is 9 and 2. So I will rewrite the square root of 9 times the square root of 2, which becomes 3 the square root of 2. So this piece will be replaced by this. But now I have to do the same thing to 50. So 50, the square root of 50 I meant. Yes? It will be replaced by 3 times the square root of 2. Because this will replace this. Perfect. So now let's look at the square root of 50, which we had before a minute ago. The square root of 50 is the square root of 25 times the square root of 2, which translates into 5 the square root of 2. And this will replace this only. And the operation is multiplication, of course. So now let's write the whole thing one more time from scratch. So we have 3 multiplied by 3 the square root of 2 plus 5, which is multiplied by 5 the square root of 2. Yes. So 9 the square root of 2 plus 25 the square root of 2. And now I will say, okay. Okay. It means that they are like radicals, and I can add them. I can say 9 apples plus 25 apples, which is 34 apples. Any questions on the problems we looked at? So simplifying, multiplying, and dividing. So we are now working on adding and subtracting from P.3. That's where we are. So let's look at one more, or more than whatever you need. And then we'll look at something else, rationalizing. And then simplifying more. Okay, should we choose another of adding and subtracting? Or we understand how this works? Moving on? Okay, so now the next step is we talked about rationalizing the denominator. So One more time, we know how to add, subtract, multiply, and divide radical expressions. This is what we just looked at. Now we want to rationalize radical expressions. I have to tell you that 99%, I shouldn't say 99%, but most of the situations we need to rationalize the denominator. But there are situations in which later on in higher level math you will see you will have to rationalize the numerator for different reasons. And we will be asked. In this set of problems, we're asked rationalize the denominator. So there are two different situations that we will look at here. One which is easier than the other. I think I have to put my tent up. Where is my tent? Here it is. Sun is coming. Okay, perfect. So one situation is when we have only one term in the denominator, like, let's say, the fifth root of x y cubed. Just one term. But the other situation is when I have the square root of x minus 3 the square root of y. I want you to see the difference. And then we will discuss each case. The first one has only one term in the denominator, not a sum of terms, not a sum of radicals. The second one has a difference of radicals. They will be treated differently. What are we trying to do? To rationalize the denominator. How do we rationalize the first one? We have 1 over the fifth root of xy cubed. I need to multiply and divide by, I don't know why, I don't know what just yet, but I want the answer to be xy. Nothing else. The numerator will be something else, of course. But I want to get xy, meaning I rationalize the denominator, meaning there is no radical in the denominator anymore. That's the meaning of rationalizing. We rationalize the denominator because we don't want a radical in the denominator.
Why is that true?
Why? For many reasons. Number one, when we divide by 5, we get a decimal number that has a terminating decimal. And when we divide by the square root of 5, we get a irrational number. We don't know where to truncate it depending on what we're doing. If we're talking about people's lives, we want the whole number. If we're talking about the length of pencils, we don't care, right? So you're going to say, well, but that's a small difference. It is a small difference, actually. But we prefer clean denominators, no radicals, because normally radicals mean irrational numbers. Numbers that have a non-terminating decimal, no pattern. I cannot change them into fractions. They're more difficult to work with. That's the main idea. In other situations, it's because you simplify and you are trying to do something else next. But here, we just want to clear the radicals from the denominator. The question is, what do I multiply by? 1. It has to be 1, but in a very specific form. The numerator and the denominator must be the same, because I cannot multiply by anything else but 1. If I multiply by 1, the result doesn't change. But that 1 means same numerator and same denominator. Now let's see the question is not right now, what do I need? First of all, it has to be the same index, because I can't multiply if they don't have the same index, right? It has to have the fifth root, mandatory. Now, how many x's should I have under the fifth root to clear the radical? The fifth root of x to which power will clear the radical? Let me write this. Maybe it's not clear if I don't write it. So I'm asking this question. X to 0 is 1. And the fifth root of 1 is 1, not x. Think of what we started with today. 3 over 5 is not 1. right? 5, of course, right? It makes sense? So if I don't have 5 here, not 6, not 5.2, not 3.9, right? If I don't have 5, 5 over 5 will not be 1, right? That number over 5 will not be 1. It must be 5. How many do I have initially? 1. How many do I need to form the 5th? How many more? Exactly. Exactly. X to the 4th and x to the 4th. Now please identify what we need for y. How many y's do we need? Of course. So this is indeed the 5th root of x to the 4th y squared. And when we multiply these two, we have to get this. We made it happen. So then the result is that. We specifically identify what we needed to get that. So when you multiply these two in the denominator, that's what you get, right? Same radical. X times x to the 4th is x to the 5th. X, y cubed times y squared is y to the 5th. So this is the entire procedure for this case. So let's look at another example. This time I'm going to pick an example from the book. Okay, let's say 46. So 2 divided by the square root of 10. I want this. What should I multiply? And divide by. It has to be the same quantity. And it has to have the same radical. There is no question there. If this is cube root, I cannot multiply by index 5. If this is the square root, I cannot multiply by index 4. It has to be the same index. But what do I need? Top and bottom.
10.
Of course. 10 to the first power. The numerator is 2 to the square root of 10. The denominator must be the square root of 10 times the square root of 10, which is the square root of 10 squared, which is 10. And yes, I will have to simplify 2 and 2, and I get the square root of 10 over 5. So this is the first situation. Not too difficult. We're going to look at other examples in a minute. Not too difficult, as long as I remember what the expression needs. Or maybe we should do one more, and then we'll look at the second one. The second one is a different story. So let's look at 1 over the 6th root of x, y squared, z to the 3rd. Assuming that x, y, and z are positive numbers. Don't worry now because it's the 6th index. The answer should have absolute value, but there is no need because we assume everything is positive. So please tell me, first of all, what do you want the result to be or have in the denominator?
XYZ.
XYZ. And now please tell me the index that you need to multiply by, top and bottom. The index first. It has to be the same, of course. Thank you very much. Yes, Jay? Very good. Awesome. The numerator is the 6th root of x to the 5th, y to the 4th, and z to the 3rd. And the denominator is guaranteed to be xyz. So this is all about the first possibility or the first case. Any questions? Okay, so let's look at case 2. On the first or the second day of classes, I think it was the second day of classes, we looked at 3 formulas. And I said this is our agreement moving forward. Can anyone refresh our memory on the third one? And then we also studied it when we factored. What was the third one? Let me see if I have it here. It doesn't matter if I do or if I don't. I'll put it up there one more time. I don't want to waste your time. Okay, here was the first one. A squared plus,
B squared.
careful, 2ab plus b squared. The other one was a minus b, everything squared. We do not need either one here. We need the third one.
A squared plus B squared.
This is what we need here.
Then it comes up top.
So we will top and bottom multiply by since we have the a minus b, we will need the a plus b to get the a squared minus b squared. So what is the a plus b in this case? If a minus b is this, the square root of x plus 3, the square root of y, the square root of x plus 3, the square root of y. So if a minus b is the square root of x minus 3, the square root of y, a plus b must be the conjugate. We call them conjugates. A plus b and a minus b are conjugates. So the initial denominator had the square root of x minus 3, the square root of y. We have to multiply by the conjugate of that. The conjugate is identical but has the opposite sign in between. The numerator has no problem. When I multiply these two, this is what I get. But now, please square the first quantity. We again assume that everything is positive. Please square the first quantity and tell me what to write. Please square the first quantity and tell me what to write. What do we get when we square the square root of x? Okay, let's say we don't know. Right? The square root of x squared is the square root of x and the square root of x, which is the square root of x squared, right? Copy the base, add the exponents. And when you take the square root of x squared, we get x, assuming that everything is positive. Otherwise, I would have had to write the absolute value. So this is x. What is the sign that I have to write next? Perfect. Please square the second quantity and tell me what you get. Exactly. Excellent. Indeed, 9y. We rationalize the denominator. We did not change the value of the fraction because we multiply by 1. Multiplying by the top and the bottom being the same, we're multiplying by 1. We're not changing anything. We're changing the presentation, but not the value of the fraction. The value stays the same. Okay, I think we need to practice more of this. So please choose, or I will. These are numerical ones. Okay, I will choose, let's say, 53. 53 on 48. Any questions for me, please? So this is 6 over the square root of 5 plus the square root of 3. This is not the first type. It's the second type. So we will be multiplying and dividing by what? The conjugate of the denominator. Excellent. And that would be?
Radical 5 minus radical 3.
Excellent, Bob. Thank you. The numerator is very clear. I just multiply them, writing them side by side. But now the denominator, remember, is a squared minus b squared. So please square the first term minus square the second term. What do we get? Five. Very good. So this is 6. The square root of 5 minus the square root of 3. 5 minus 3 is 2. Now I'm allowed to simplify. So the final simplified form, you do not need to distribute, is this. Any questions? Any questions for me? Yes, of course. I want to choose from 16. So I'm going to choose from a different page. Right before radical equations. Because that was in the warm-up and now this is slightly more sophisticated. And I let you choose. Yes? Ready? Which one?